So the third speaker is a special guest, also a member of the Zigurat community. Luis Briones Alonso is the BIM manager at Arcade, and he's just about to finish the master in BIM management here at Zigurat. Arcade is a Belgian multidisciplinary engineering firm, and we're very happy to have him as a speaker because a few days ago, we signed a partnership agreement between Arcade and Zigurat. He will talk about an interesting project and how he can use BIM during construction for high-tech facilities, a sustainable fish farm located in Belgium. Luis, welcome and feel free to amaze us.
Thank you very much, Rodrigo. Can everybody hear me well?
Yeah, very good.
All right, let me just share my screen. Let me know if you can see it.
Yeah, we can see it now.
All right, then I'll get started. So good afternoon, everybody. My name is Luis, and I'm going to talk about BIM implementation strategies. As Rodrigo mentioned, it's going to be a case study of how we developed the BIM strategy for specifically construction is what I'm going to focus on today for a high-tech fish production facility. So I think Rodrigo introduced me quite well and mentioned everything. I am the BIM manager at Arcade, a Belgian multidisciplinary engineering company. And I am also currently a student at the Zigurat Global Institute of Technology doing a master's in global BIM management. Some background info about Arcade and what we do. So we were founded in 1986 as a family company, but we've grown to about 45 employees since, with 2 locations in Belgium. And we currently have 6 departments. The most recent of which that was founded is the BIM department that I'm developing together with my colleagues. And there we focus on 3 big services: BIM management, consultancy, and coordination. And the important one here is BIM consultancy for the project that I will be discussing, because there we were the advisors of the client to try and help them define how to best implement BIM and technology in all life cycles of their facility. Maybe some short info on our philosophy as well. So we are firm believers in open BIM principle and following the ISO workflow. We are in the process of getting certified for that as well. And it's also the workflow that we followed for this project, the case study that I will be mentioning. I'm not going to go into detail on the specifics of the ISO. I don't think that's most interesting for here, but I'm going to approach it in a more general sense of the mindset and tactics that we use to try to analyze and determine how to best utilize BIM for a project. Yeah, so this brings me to the project at hand. Columbi Salmon is the client that we work for, and it's a Norwegian collective of salmon industry veterans, and they have a passion for trying to develop truly sustainable fish farming. And to that end, they are going to build a salmon production facility, a land-based salmon production facility in Ostende, Belgium. They're very innovative, and they're also very focused on trying to really use technology to find an answer to the challenges that this project brings with it, because it's a very unique project. I'm going to go into detail on why I believe that is, especially when we're talking about BIM. But we as Arcade were hired by Columbi to help them assess what the optimal BIM strategy would be and how we could use technology to really drive innovation for this construction and design and operation as well. Before going further on that note, I want to give a quick explanation on what I will be focusing on here. So as I mentioned, there is a lot of technological advancement related to BIM, a lot of applications, scanning, virtual reality, augmented reality. I'm not going to go into focus on any specific technological application, but what I'm going to focus on is the approach and the mindset that I mentioned earlier on how to determine what the priority should be for technological application in a project. because there are so many applications, and it's quite easy to lose track of the fact that the technological applications need to be there to support the end goal. And the end goal is improved design, improved construction, and improved operation, or whatever else you would like. And it's important to keep our eyes on the prize, in a matter of speaking, and to make sure that we don't fall into the trap of losing ourselves in the amazing possibilities that the technology brings with it, and start seeing those applications as the goal instead of the means to a goal. And you see this a lot with tenders going out with a plethora of BIM uses or technological applications that are taken from standard templates, but they're not fit for purpose, and they are not really answering a need for a project or a need for a client. They are there to just use it because it's well, interesting or cool or whatever. So that's going to be the focus of my presentation. And the first important thing for our approach here is that there are a number of key questions that we believe that need to be looked at for every project and for every client. And those key questions are what the defining features of every project and the defining features of every client are, what their specific or what the specifications are, or what makes it unique or what makes it different than other projects or other clients. Of course, there are BIM uses that are interesting for every client, like cost estimation or improved planning and things like that. But really, when you're developing a BIM strategy, it's important to start from what is unique or specific for this project and what should be the priority. You can use a lot of applications, but it's important to determine the key challenges of every project and the key goals of every client before you can start thinking about what the priority of every technological application should be. And that's what we did for this project. And I'm going to discuss three really key challenges that we found for this project. And the first one is that it's a fish production facility, salmon production facility. And that means that there is a very high-tech recirculating aquaculture system or RES system that really defines the construction. So it's not with regular MEP engineering, or usually the standard way of approaching it is you have a design of a building, that's the basis, and then you see how you can fit in the facilities in it. But it's switched around here because everything is based on these RES systems. These are immense, intricate, high-tech piping systems with immense tanks. They have very specific spatial requirements. They have very specific requirements on layout, also for the sequence, because they support the fish throughout their entire life cycle, starting from inception as eggs up until they grow in various stages. They go throughout the facility, and at the end they are adult and harvested for meat, etc. So that's a very specific thing about this facility, and the most important thing. And that brings a lot of changes with it to how you would usually approach something like a standard warehouse to keep it in the same sector or something like that. Another very specific thing was that there were very strict construction planning demands, because as I mentioned, these facilities, they support the fish starting from inception as eggs until they grow to their adult stage. So that means that in production, there is also a time needed for inception of the eggs until they are grown. And if you wait for the entire facility to be built first before you start implementing the eggs to start the process, you lose a lot of time and a lot of possible production, because you can focus on constructing the part of the facility that's meant for implementing the eggs first. As soon as that's finished, you can implement the eggs and start the processes there and move on to the next construction part, and really in a sequential order, in a sort of cascade system, keep construction going while you put certain parts of the facility into operation. And of course, this comes with very high demands for the planning, small room for error, and there's a high risk of conflicts between operation and planning. So a very big challenge that would be hard to meet in a classical approach. Also, the fact that there is a lot of safety risks and hazards involved with people working next to construction sites or in parts of facilities where people are flowing in personnel, and there are also flow of construction logistics nearby, things like that. So that's the second key feature that we determined that we need to take into high priority when determining the BIM strategy. And then the final, or the third one, not the final one, but the third one that I will discuss here, is the extremely high operational risk when there is operational failure. In a usual production facility, if there's operational failure, you lose money, you lose productivity. But here it's even more so because it's living creatures. And if there is long-term failure that causes the fish to die, that's extremely high costs, but also extremely high sustainability costs. And Columbia Salmon is very focused on sustainability. It's the whole purpose for their construction of the facility here. So that's an added risk that you don't really find in a lot of other similar facilities. That was also determined to be very high priority and very much a key defining feature of this project. So this brings us to the next piece of the puzzle. How does this relate to BIM? How can we support these peculiarities of the project with BIM and technology and digital ways of working? Of course, this goes a lot further than just the construction phase, but considering that that's the focus of today, I am going to focus on how we are going to try to answer this during the construction. This has an impact on design, starting from design until operations, but there are some very specific ways in which we want to support these challenges during construction as well. And the first one is an answer to the RAS demands. So as I mentioned, there are very specific requirements spatially for the RAS demands. Unfortunately, you have to build the building first before you can build the RAS facilities, but the RAS facilities are the most important part and the most sensitive part in a matter of speaking. So as you can see on the picture in the bottom left, it's a very intricate system. There is very little room for error. Of course, in the design, you will use coordination and clash detection to make sure that the designs are all right and that everything is accounted for. But still, you have always a risk of deviation between what is constructed and how it was supposed to be constructed. And how we're going to handle that is we're going to use point cloud validation by having periodic scans on site as the facility is being constructed. So as it's being constructed, we're going to take point cloud scans. You can validate them against the design models. And all the elements that are constructed need to be approved in that way as being either compliant with the design or not compliant with the design. If they're not compliant with the design, this will allow us to proactively look what is the impact adjusted in the models, see if it has a negative impact on the piping systems, if we can solve it, if we need to find other solutions for the RAS systems. But this will ensure that we stay ahead of the curve. And as soon as something is built, if you do it frequently enough, we will always have the ability to intervene when things are not going as they are planned, and we can keep control of how things are constructed to make sure that there are no negative consequences of deviations on the RAS facility. The next part that we tried to answer was perhaps the most challenging part, which is the strict demands for planning. As I mentioned, safety and hazard risks, little room for error, very high impact of delays, even more so than in other projects. And it's also a very complex facility. There are a lot of elements, and standard planning methods are not going to be sufficient to account for everything. So what we want to do here is start with the construction planning based on the models in a very early stage of the design already and keep it going through construction. So what happens a lot with 4D BIM, I'm sure everybody's familiar with that, with construction planning and logistics planning, is that the model is made, the planning is made, they are linked together and simulated, and then you can see it in a 3D environment how the planning is made. The idea is here that we really use the models at first and in an iterative process and try to check all the elements to make sure they are linked together, that we really do it in a collaborative manner as well, because there are a lot of experts whose input is needed for determining the planning. It's, the safety expert needs to make sure that there are no risks between operation and construction. We have the RAS experts that need to make sure that the facilities can function and there are no risks of failure of equipment due to construction flow, or that there's no room for maintenance because some parts are being in construction. So the idea is to first really start from the models and collaboratively work by simulating step by step how the construction is planned and getting input from everybody. And also during construction to keep this updated with how the construction is progressing, so that we updated with what is in construction, what is already construction, very importantly, what is validated with point clouds, so that we can be sure that those sections of the facility are constructed, validated, and that we can start there with implementing or building the rest facilities, so they can be put into operation in that sequential order. And if there are any delays, then that also needs to be updated, of course, in the planning, so we can assess what the impact will be for the rest of the facility if there are new risks and hazards or conflicts coming through there. So that's how we are going to use technology in the construction phase to try to stay ahead of that curve and then make sure that everything goes smoothly. And then last but not least is the operational risks. It's of course very much more related to operation and maintenance rather than construction, but I still want to mention it because you need to know what information you need in operation before you start construction, because it's even for very simple things. For example, if you need to know for your maintenance strategy when certain equipment was placed and what the serial code for that piece of equipment was, you need to know that and implement it and link it to the database while you are constructing it or immediately after you're constructing it in a digital way. Because if you don't do that, you do it retroactively or you do it on paper and you type it over to your database, you have a much higher risk of error, especially with the large amount of elements that we have here. It could be bad handwriting, it could be a typo, it could be reading it wrong or whatever it is. And you have a massive loss of efficiency because, of course, if you place all your equipment and you need to go back and check the serial codes and link it to the database, then I'm sure everybody here has struggled at one time in their life trying to find the password on a Wi-Fi router that was placed near a wall or something like that. Just imagine having to do that for hundreds of pieces of equipment just to be able to link it to your database. It would be extremely inefficient. So it's a lot smaller impact during construction, but with large consequences if it's not implemented correctly, especially taking into account the way we want to put certain parts in operation as soon as possible after they're constructed. So I just wanted to mention that because I focused on construction here, but even though we have all these amazing technological applications and things we can use during construction, a large part of successfully implementing technology and digital workflows in construction is still based on proper planning, on proper collaboration, communication, and making sure that everything is accounted for from the start, because in my opinion, that is the key for having a successful BIM implementation, by taking into account the unique needs of a project and planning your priorities accordingly. So on that note, I want to thank everybody for your attention. And if you have any questions or anything else, feel free to contact me. And just thank you for having me, for you as well, you and everybody else at Ziggurat. And I want to wish everybody else a nice day. Thank you.